Hi everyone. This lesson recap for the solving trig equations, which again we've covered last year. But this topic is really important because all of you will be doing stage 2 methods, and these are really important for both methods and specialists. So it is worth spending some time to make sure that you know the correct and the best methodology. Okay. So I put on some question here. Again, I'm highly advise you to copy those questions and then attempt in your book and then compare your answer with my answer. Okay. So the strategy to solve this type of question is basically first have a look at the domain. Okay. The domain is 0 to 3 pi. So your answer will have to be in the domain. If it's not in the domain, then that's wrong. Okay. So we could easily solve this type of trig equation by using a unit circle. So when will sin x be a negative pi on 2? That's going to be here and here. Okay, so you can actually do negative pi on 6, and this one is negative 5 pi on 6. Okay, and then you can easily solve by x equals to negative pi on 6 plus 2k pi, and then x equals to negative 5 pi on 6 plus 2k pi. Okay, this is your first step. Okay, first step, finding the value on the unit circle. Okay, finding the value on the unit circle. Second, write in the plus 2k pi form. Okay, third, you can get your answers by aligning your answer here by using your domain to get exact answer. Okay, so because I've got 0 to 3 pi, so obviously I cannot having positive value. Okay, so if my k, so letting k equals to different integers is basically what you need to do. So here we know from the domain k cannot be negative and cannot be 0 because you end up with a negative value. Okay, so with that one, so k has to be 1, okay? K cannot be 2 because if k equals to 2, that's going to be 4 pi. 4 pi take away pi on 6, that's above 3 pi. So when k equals to 1, this one will be 2 pi take pi on 6, 11 pi on 6, okay? Second one will be x equals to negative 5 pi. And again, k has to be 1. Can't be 0 or below 0, okay? If k equals to 1, plus 2k pi, plus 2k pi, k equals to 1. So therefore, x equals to 6, 12 pi, take away 6, 5 pi. So that's going to be 7 pi over 6, okay? So you end up with two answers. So x equals to 11 pi on 6 and 7 pi on 6, okay? So that's the strategy of doing that. 3 steps. Okay, let's have a look at the second one. Each time you have something behind it, okay? You have something behind it. You see these and these as a whole. And that's how you solve these type of questions, okay? So you can just do same as the previous one. 2x is negative pi on 6 plus 2k pi. Here, or 2x equals to negative 5 pi on 6 plus 2k pi. Okay, so from the first equation, you can have x equals to negative plus k pi. Second one, you can have x equals to negative plus k pi. Okay, so this is your new equation. Okay, then you align your answer based on the domain, which is from 0 to 3 pi. So knowing that it's only from 0 to 3 pi, again, k cannot be 0. Okay, so the first one, x equals to plus k pi. So k can be, well, I'll just write down here. It's actually easier to write down here. So k is 1, so k can be 1. And 2 is obviously okay, because 2 pi take away pi on 12 is still in the domain. And 3 is okay because 3 pi take pi on 12 will be below 3 pi. But 4 will not be okay because it will be above 3 pi. Same with here, k is 1, 2, 3, okay? So, and then we calculate it. When k equals to 1, 11, 12 pi, okay? And we keep writing the answer. So 23 pi, and then 35 pi. And the second lot of answer will be, let's see, so 12, 7 pi, and then 19 pi, 12. The last one will be when k equals to 3, 36 take 5, 31 over 12 pi. Okay, so you end up with 6 values. Understand? Let's have a look at the last one. So x take pi on 6, you do the same thing, okay? Pi on 6 plus 2k pi. X take pi on 6 equals to 5 pi 6 plus 2k pi. Okay, you still end up with the, with the 2 equation, and then you rearrange the equation. Okay, x equals to, you just put the k pi on the other side. With the first one, you end up with 2k pi, and with the second one, you end up with negative 2 pi 3 plus 2k pi. All right. Okay, now, and then you can trial different k value. So k can be 0 because 0 is in the domain. K can be 1 as well, but k can't be 2 because 4 pi is over. Okay, so k cannot be 0, can be 1, and cannot be 2 because 4 pi take 2 pi on 3 will be above 3 pi. Okay, so you can write down the answer now. X equals to 0, 2 pi, which is the first one, okay? And then the third one will be 2 pi take 2 pi on 3, which is 6 take 2 is 4 pi on 3. Yeah? So I'm with 3 answer. Yeah. So you can see how I did it is by just treating whatever behind as a whole thing. So I think it's a very easy way of doing things. Try to get used to that. And then you can trial different k value to see which one is in the domain. Okay. Okay. I've just put on another question here. You can see it's a little bit more complicated, but not so much. And the strategy still doesn't change. Okay. So you always treat these as a whole, but your goal first is to isolate this part. Okay, you need to put in a cos equals to whatever form to be able to solve the trig equation. Okay, let's just do it together. So your first is to rearrange cos x take 3 pi on 4 is you take away 1 divided by root 3. So, oh sorry, I copied the wrong thing. I think it's root 2. Okay, yeah. So you take away 1 divided by root 2. So 1 negative root 2. Okay, this is your first step. After that, you again go to the unit circle. Remember the steps. Okay, go to unit circle where cos is negative here and here. Okay, you have 3 pi on 4. Here you have, that's 5 pi on 4. Okay, so you can write it out. Take 3 pi on 4 equals to 3 pi on 4 plus 2k pi. X take 3 pi on 4 equals to 5 pi on 4 plus 2k pi. You've got your 2 equations. And then again, you can rearrange it. X equals to, yeah, okay. And then the other one is x equals to 2 pi plus 2k pi. Yeah, okay. So now to solve this one, what does k has to be? Because I know the domain is from 0 to 2 pi. So let's see. K can be 0, no problem. Okay, k can be 0. And k can be 1, that's no problem because 2 pi plus 1.5 is 3.5, so that's fine. K can be 2, that's no problem. 4 pi plus 1.5, 5.5. K cannot be 3 because 6 pi plus 1.5 is above, okay? Second one can be 0. Well, in fact, the second one, let's have a look. So, K can be negative, because if k is negative 1, negative 2 pi plus 2 pi is 0, which is in the domain. So it can be negative 1, 0, that's no problem because it's 2 pi, and 1 is no problem because 2 pi plus 2 pi is 4 pi, and also can be 2 because 4 pi plus 2 pi is 6 pi. So this question you end up with 1, 2, 3, 4, 5, 6, 7 answers. Okay, let's write it up. So first one from here. Okay, so k is 0. Second answer, 1.5 plus 2, 3.5, 7. Third answer, plus 1.5 plus 4, that's 2, 11 pi. Yeah, and from the second one, we can see is 0. When k equals to 0, that's going to be 2 pi, and then 4 pi, 6 pi. There you go. Okay, those are the answers for this equation. All right. Okay, we'll do another one. Okay, another question. So again, what I do first is to find the whatever tangent equals to 1 on unit circle. That's pi on 4. This is 3 pi. No, 3 pi, 5 pi on 4. 5 pi on 4. Okay, so I can simply write it as plus k pi because tangent period is k pi. Okay, so 2x take equals to pi on 4 plus k pi. Okay, and then rearrange it. So plus pi on 3, that's going to be 12/7 pi plus k pi. Divide by 2, x equals to 24/7 pi plus half pi times k. Yeah, and then we can play with the k value to make sure that x is in the domain. Okay, so let's see. All right, we could put in a common denominator if that's easier for you. K obviously can be some negative value, but you know, because they've got negative pi here, but let's see how far it can go. Okay, so if k is negative 2, let's see, k is negative 2, that's gonna be, I'll just calculate it here. If k is negative 2, 7 pi 24 take pi will be 24/17 pi. Okay, that's my first value. K can't be negative 3 because if k is negative 3, let's see, it's actually going to be exceed the value. Let's try that. I think it's going to exceed the value. Negative 3, so take 2, 3 pi, and then that's going to be 24/7 pi, take 24, negative, yeah, obviously it's above. Yeah, so that's not gonna work. Okay, so can't be negative 3. So if negative 2, I'm pretty confident it's negative 1, and then 0, and k can be 1. K can't be 2 though, because it's pi plus a positive, that's gonna be above. Okay, let's calculate, we've calculated negative 2, let's calculate it negative 1. So that's gonna be 7 pi over 24, take pi on 2, that's gonna be negative 24 pi, and then 0, easy, so, and then equals to 1, that's gonna be u plus 48 over, and that's 1924. Okay, yeah, so this is how you do it. You plug in different k value to make sure that it's in the domain. Okay, so yeah, so I hope you guys learned the methodology from these few questions, and then if you have any question, just please feel free to ask me. Okay.